All of you know about the electron displacement effect. The inductive effect is a type of electron displacement effect as you have studied in the plus 2 syllabus. What is inductive effect? When an electron releasing or an electron withdrawing species is introduced to a chain of atoms, the corresponding negative or positive charge is relayed through the carbon atom by the atoms belonging it. This causes a permanent dipole to arise in the molecule and is referred to as inductive effect. For example, ethyl chloride. In this, the electronegative chlorine atom withdraw electrons. The group chlorine attracting the electrons towards itself due to the difference of the electronegativity by induction of polarity in an otherwise non-polar bond due to the attachment of a more electronegative atom in the chain. This is known as the inductive effect. The atoms or groups is electronegative than carbon withdraw the electrons and this carbon chain to withdraw the electrons of the carbon chain towards themselves, and it is known as the minus I effect. And if a more electropositive group is attached to an otherwise non-polar carbon atom, the Y gets the fractional positive charge and the carbon linked to it gets a fractional negative charge. And these atoms or groups which are more electropositive than carbon chain, a slight positive charge on them push the electrons of the carbon chain away from themselves. This is known as the plus I effect. The inductive effect has the following characteristics. It is a permanent effect. It operates through sigma bonds. Its magnitude goes on decreasing with increase in the distance from the atom or group responsible for the same. These are some of the groups which show minus I effect. In this, the minus I effect of some groups is in the order minus I effect, that is H, C6H5, OCH3 less than OH less than I less than Br, Cl, F, COH, Cn, NO2, N plus CH3 thrice. Plus I effect of the same groups, some of the groups, hydrogen, deuterium, CH3, CH2R, CHR2, CR3, CO. Inductive effect is not a hypothetical phenomenon, but it actually operative in the molecule. This has been demonstrated by the fact that it is commonly used to explain the properties like origin of dipole moment, increase or decrease in the bond length, strength of acids or base, etc. How to compare the extent of minus I effect or plus I effect in the comparable groups? Minus I effect here, due to electronegativity of the first atom, electrons are withdrawn or pulled towards itself. The order of minus I effect between the following groups NCH3 twice, NHCH3, NH2, NHCOCH3. Plus I effect here, due to the electropositivity of the first atom, the electrons are pushed away from itself. In this, the plus I effect, if they also pushed by plus I effect, but will decrease the plus I effect if they are electron withdrawing by minus I effect. The plus I effect follows this order. The inductive effect of a group depends on this parameter. First one is the electronegativity, bonding order and charge, position within a structure. Electronegativity atoms like nitrogen, halogens, oxygen, etc. must have negative inductive effect. Due to the minus I effect, these electronegative atoms withdraw electron density through the single bond and can assist in the stabilization of negative charge that may form in the reactions like carbanions, oxygen anions, etc. On the contrary, they shall destabilize the positively charged species like carbocation and electron deficient species like free radicals. Minus I effect groups have a stabilizing effect on the ionization of acid. For example, out of acetic acid, chloroacetic acid and trichloroacetic acid. Trichloroacetic acid is the strongest acid. Inductive effect and carbocation stability. Primary carbocation, methyl, primary, secondary and tertiary. Least stable ആയതാണ്. Methyl carbocation. Tertiary carbocation is more stable. In this, the methyl group shows plus I effect. Bond polarization and inductive effect. Minus I inductive effect. CF group is more minus I effect because the fluorine is more electronegative. Plus I effect CS3 thrice. Inductive effects are of short range in contrast to the resonance effect. This order we see in the previous slide. And then come to the applications of this inductive effect. First one is the acidity of chloroacetic acid versus acetic acid. In this, the chlorine is a more electronegative atom, and thus the electron deficiency on the carbon and oxygen in the chloroacetic acid, which is compared to the acetic acid, and hence this release of the proton from OH is more easy. So the chloroacetic acid is more stronger than that of acetic acid. Come to dichloroacetic acid, trichloroacetic acid, the electron withdrawing effect should increase greater. Dichloroacetic acid is more stronger than chloroacetic acid, and trichloroacetic acid, which in turn is more stronger than dichloroacetic acid. To sum up, the decreasing order of the acid strength in this series is trichloroacetic acid, dichloroacetic acid, chloroacetic acid and acetic acid. Second application is the relative strength of formic acid and acetic acid. We all know the structure of formic acid and acetic acid. In this, the methyl group in the acetic acid has an electron releasing inductive effect, the plus I effect, and hence the acetic acid is weaker than that of formic acid. Relative strength of fluoroacetic acid, chloroacetic acid, bromoacetic acid and iodoacetic acid. In this, the electronegativity of the different halogens is considered. For example, fluorine is more electronegative than chlorine, than bromine, than iodine, and hence this decreasing order of this electron withdrawing inductive effect is fluoroacetic acid is has high inductive effect than chloroacetic acid, than bromoacetic acid and iodoacetic acid. Next application is the relative reactivity of toluene and benzene in the electrophilic substitution reaction. Aromatic substitution reactions are generally electrophilic. Methyl has an electron releasing inductive effect, and hence the toluene with higher density than benzene, electron density than benzene, enhances its reactivity in the electrophilic substitution reaction, and hence this toluene is more reactive, which is due to the plus I. Next application is the relative reactivity of nitrobenzene and benzene in the electrophilic substitution reaction. In this, the nitrobenzene is an electron withdrawing group and shows low electron density, and hence less reactive to electrophilic substitution reaction. Next is important application is the relative basicity of methylamine and ammonia. Due to the electron releasing inductive effect, that is plus I effect of the methyl group, methylamine has higher electron density on nitrogen than ammonia. Methylamine is a stronger base than ammonia. It can be shown from the pKb values that methylamine is more basic. pKb of 3.37 for methylamine and 4.74 for ammonia. And similarly, dimethylamine will be stronger than methylamine due to the plus I effect caused by the two methyl groups. It can be shown by the pKb values. And then the electronegativity of 2-chloro, 3-chloro and 4-chloro butanoic acid versus the butanoic acid. From this, the pK values of all the acids shown that the chlorine substituted at nearby COH group is more stronger acidic than that of the beta position chlorine group and then gamma. And this shows that the inductive effect decreases as the distance increases. That is, 2-chloro is more stronger than 3-chloro, which is more stronger than 4-chloro than butanoic acid. From this, the inductive effect is also almost negligible beyond the 2 carbon atoms from the active atom or groups. And hence, from this, we conclude that the atom or group, the inductive effect of an atom or group diminishes rapidly with the distance. Then the relative stability of methyl, ethyl, isopropyl and tertiary butyl cations, that is carbocation stability, we explain by the plus I effect, that the electron releasing inductive effect. That is, the tertiary carbocation is more stable than secondary, which in turn is more stable than primary than methyl carbocation. Then the relative reactivities of aldehydes and ketones. Electron releasing plus I effect increases the electron availability of the carbonyl carbon and therefore decreases the rate of nucleophilic adhesion. On the other hand, the electron withdrawing minus I effect decreases the electron availability of carbonyl carbon and thereby increases the rate of nucleophilic adhesion. This is the rate of decreasing order of nucleophilic adhesion. And next application is the impact on dipole moment. As you all know that HF has high dipole moment than HCl, which in turn is higher than that of HBr. Greater is the polarity, higher will be the dipole moment, and thus the inductive effect influences the polarization of a bond. Thank you.